Okay, today we're going to get two more operational rules for derivatives of functions. We're going to talk about how to find the derivative of two functions that have been multiplied or divided. We'll call this the product rule for multiplication of two functions and the quotient rule for division of two functions. So we'll start with an example. We haven't talked about the derivative of e to the x yet, but I think you noticed from your lab that the derivative of e to the x is itself. So we're going to consider this function, e to the x times 2x squared minus 3x. We can't multiply e to the x in and simplify it down to a sum or difference in the same way we were doing in last night's homework. So we don't have a rule for this. We have two functions multiplied and we don't have a rule for it. We want to be able to separate the two functions that are being multiplied. We'll call them f and g. And so we need a rule. The two functions that are being multiplied here are e to the x and 2x squared minus 3x. So our first impulse is probably to just find the derivatives of each piece. So in that case, our guess for the derivative of this function might be m prime of x. The derivative of e to the x is e to the x, I remember. And the derivative of 2x squared would be 4x minus 3. That's just the derivative of each. And I'm going to put a big question mark beside that because I'm just testing it. I'm not sure that that's going to be the derivative. And if I look, I want to compare, I'm going to think about the derivative graphically like we were doing in the last chapter. So the blue graph here I have is just of m of x, of e to the x times 2x squared minus 3x. And if I were just ignoring anything else and kind of thinking about the derivative of this function, I know that I should have a 0 on the derivative graph right there. I should have a 0 on the derivative graph right here. And so I should end up with my derivative graph. The slopes are kind of close to 0 right there, so I would have something kind of close to 0. Then I see an increase in my derivative right through here. The derivative is 0. Then it's probably at its most negative, kind of right around 0. It comes back up, hits that 0. I kind of missed it there, but I should be 0 kind of right there. If I compare that to the graph of just my guess function up here, e to the x times 4x plus 3, then I can see that my red graph, which has to be the graph of the derivative, and my guess graph are not the same. So the derivative of the product of two functions is not just the product of the two functions. It's not just f prime times g prime. So I need a different derivative rule. And that we'll prove this later on, but this is the derivative of the product of two functions. Notice that it gets much bigger. So the derivative of f times g is f prime times g plus f times g prime. Or in words, the derivative of the product of two functions is the derivative of the first function times the second unchanged plus the first unchanged times the derivative of the second. The derivative of the first times the second unchanged plus the first times the derivative of the second. Let's do a couple of examples. Here, our very first example is the example problem that we started with. So it seems to me that if f of x is e to the x times 2x squared, here's my function f, here's my function g, and I am just going to I'm going to write them over here to the side, but I'm only going to do that one time. So I can see that f is e to the x. Its derivative is e to the x. G is 2x squared minus 3x. Its derivative is 4x minus 3. I know that since I have a product of two functions here, the derivative of this overall function is going to be the derivative of the first, so e to the x, times the second unchanged, so f prime times g, times 2x squared minus 3x, plus, and this would normally be, well, maybe I can go that way. I'm trying to get it all in one line, plus the first unchanged, e to the x, this way, times the derivative of g, times 4x minus 3. Now my goal will be to be able to produce this derivative without writing out f and g and f prime and g prime, but you write those for as long as you need to write them in order to get the correct answer. The key here is to get the correct answer. So notice that I end up with the derivative of the product of the two is f prime times g, this way, plus f times g prime. I'm going to do the second problem here without writing out f and g. I am, however, going to rewrite x, the square root of x. So that first function is just going to stay like it is. But I am going to rewrite the square root of x as x to the 1/2. I could do this problem the way I was doing problems last night by multiplying in and adding exponents. Because I'm practicing product rule, I'm going to use the product rule, but you have your choice of how to do this. So the derivative is, here's my f, here's my g. The derivative of the first, the derivative of 3x squared plus 5x is 6x plus 5 times the second unchanged, times x to the 1/2. Plus the first unchanged times the derivative of the second. I'm going to bring the power down, subtract 1 off the power. And I can leave my answer like that. You could certainly simplify if you wanted. I don't, but you could. And eventually when we need to solve these, we'll talk about simplifying. But for right now, if we have the correct derivative. So again, notice that we have f prime times, here's g, plus, here's f, unchanged, times g prime. So you can see our rule at work there. We also need a rule for the quotient of two functions. So when two functions are divided and we can't simplify it into a sum or difference, there's an example there. It's related to the product rule. Notice how similar the numerator looks to the example we just did. The only thing we changed was minus instead of plus, and we have a denominator now, all over the denominator squared. So the derivative of the quotient of two functions is the derivative of the numerator times the denominator unchanged, minus the numerator times the derivative of the denominator all over the denominator squared. Don't forget your denominator when you're using quotient rule. I have a student a few years ago who called the product rule fig figgy. So here you have fig figgy divided by g squared, if that helps you remember the rule fig figgy. So let's do a couple of examples of the quotient rule. Quotient rule, it's more obvious what f and g are. Again, for the first one, I'm going to write out f and g and f prime and g prime so that you can see what I'm doing. In the second one, I won't. Your goal is to get to where you don't have to write them out. But in the first one, my numerator is 2x. Its derivative is 2. My denominator is x squared plus 3x. Its derivative, bring the power down, subtract, bring the power down, subtract, is 2x minus 3. Then in order to find my derivative, since it's a quotient, I know my derivative will be fig minus figgy all over g squared. So my derivative will be f prime times g minus f times g prime all divided by g squared. I'm not going to square that out. So normally I wouldn't, you don't have to simplify from here. You may leave your answer this way. That numerator's bothering me a little bit. I think there may be some things that we can simplify, so I'm going to go ahead and multiply the numerator. Do a little algebra here. So 2 times x squared would leave me with 2x squared. 2 times 3x would leave me with 6x. Then I'm going to see this as negative 2x, so negative 2x times negative 2x would leave me with positive negative 2x times positive negative 4x squared. Negative 2x times 3 would leave me with negative 6x, all over my g squared. Then this does reduce there, I can combine my 2x squared, my negative 4x squared, and that makes negative 2x squared divided by x squared plus 3x quantity squared. So you can leave it here, this would be fine, or you can simplify it down. That's a little nicer answer there. It's much more compact, but either way is okay. Notice that there's f prime times g minus f times g prime all over g squared. The second example I'm going to try to do without writing out f and g. So here we go, f prime of x. So my derivative is going to be the derivative of the numerator. The derivative of 5x is 5 times the denominator unchanged minus the numerator unchanged times the derivative of the denominator all over the denominator squared. Again, I could simplify the numerator if I wanted to. Oh, let's write on this. So let's relabel. So here's f prime. Here's g. Here's f. Here's g prime. And here's g squared. So I did follow my rule for finding the derivative. I could simplify a bit again. 5 times x cubed plus 1 makes 5x cubed plus 5. Then negative 5x times 3x squared makes minus 15x cubed all over my denominator squared, x cubed plus 1 squared. Then I could combine like terms. 5x cubed minus 15x cubed makes negative 10x cubed, and then x cubed plus 1 squared. And I have my derivative. Perhaps a nicer version. Again, you can leave it here. That would be fine. Or you can simplify it down to the more simple answer. All right, that's it for today.